We have a couple more examples to solve some systems of linear inequalities. Number 4, we have y is greater than x minus 3, and 3x minus 6y is less than or equal to 12. Now the first inequality in this system is already in slope-intercept form, so we don't need to move anything around there. I'm going to go ahead and graph that, and then I'll worry about the second inequality. This one is strictly greater than, so we have a dashed line. And now we can move on to the other line. We need to get y by itself, so I'm going to start by subtracting 3x from both sides. And then I'm going to divide by 6 so that y is all alone. But notice it's a negative 6, so we need to switch that sign. So we have y is now greater than or equal to 3 over 6 reduces to 1/2 x. 12 over negative 6 is negative 2. So we have a y-intercept at negative 2. This one's greater than or equal to, so it's going to have a solid line. And now we shade. The red line we want to be greater than, so we want to be above the red line. And the blue line we also want to be greater than, so we want to be above the blue line. So everything that is above both lines at the same time. So notice in this really, really skinny region, we're above the blue line, but we're not above the red line, so that doesn't count. In this skinny region, we're above the red line, but we're not above the blue line, so that doesn't count. So we're going to do everything that's above both lines, which is this entire region up here. And that's what we're shading in. So any solution that we pick has to be in this shaded region, or along the blue line, since it's solid, that is touching that shaded region. So some examples of solutions might be 0, 0, or negative 2, negative 3. Some examples that are not solutions might be 3, 0, since it's on a dotted line, or 3, negative 2. It's not even in the shaded region at all. Negative 2y minus 5x is greater than 2. Negative 5x is less than or equal to 2y minus 4. We need to solve for y in both inequalities. So in the top one, adding 5x, we have negative 2y is greater than 5x plus 2. Then dividing by negative 2, we switch our sign. Y is less than negative 5 over 2x minus 1. So there's our first inequality. Then in our second one, we need to move the 4 over. So we have negative 5x plus 4 less than or equal to 2y. And then divide everything by 2. Negative 5 over 2x plus 2 is less than y. Now this one I'm going to rewrite it to where y is on the left so that it's easier for me to see where my shading is going to go. But I need to make sure I keep the arrow pointing in the correct direction. So y is greater than negative 5 over 2x plus 2. Now let's graph. For the blue line, we have a y-intercept of negative 1. Our slope is negative 5 over 2, so we can go up 5 and to the left 2, or down 5 and to the right 2. Strictly less than, so we have a dashed line. Now for the red line, we have a y-intercept of 2. This time we have the same slope, so we can go up 5 and to the left 2. This one is also going to be a dashed line. And now we can shade. So, if we want to be less than the blue line, we would want to be underneath it. If we want to be greater than the red line, we would want to be above it. Those two regions, I'll shade them very lightly, those two regions do not overlap at all. They are never going to touch. The reason that we know that is because the slopes of both of these inequalities is the exact same. They both have a slope of negative 5 over 2. That means those lines will never touch, so they'll never have any sort of intersection. And because we have strictly less than for the blue line and strictly greater than for the red line, they are not going to overlap. So this one has no solutions.